Welcome to Chapter 14, Lesson 9. This lesson is all about quadrilaterals. All quadrilaterals have 4 sides and 4 angles. There are many different kinds of quadrilaterals. So when we see this word quad means 4. Quad means 4. If you've ever heard of the word quadruplets, that means kind of like twins, but when 4 kids are born at the same time, 4 babies are born at the same time. Quadruplets. Quadruplets. Are there any other words you can think of that have quad in them? So quadrilateral, lateral means side or line or side. So when you put it together, quadrilateral, it means a 4-sided or 4-lined figure. So to be a quadrilateral, all you have to have is 4 lines and 4 angles, be a closed figure. So that means you have to close. So 1, 2, 3, 4. Okay, but you couldn't have like 1, 2, 3, 4. Well, that's 5, but, or let's see, 1, 2, 3, and 4, like this, where it's open. This would be open. So this is not a quadrilateral. It has to complete itself and be closed to be a quadrilateral. Okay. Once you've established that you have a quadrilateral, there are a couple other types of quadrilaterals. So before we get into the example, let's look on the back at our purple box that has our key concepts, and it gives us some examples of some different kinds of quadrilaterals. Okay, and to be a certain type of quadrilateral, there are rules. So the first one we have, it says a parallelogram. Well, if you think of the word parallelogram, you hear the word parallel in it. And so that gives you a clue that we need to look for parallel lines. And that's one of the main things we look for when we're thinking about classifying or naming quadrilaterals. Parallel lines. You have to ask yourself this question. Parallel lines. So a parallelogram, and I have one right here for you, lucky enough, has opposite sides that are equal in length. So what that means is that this side here and this side, if we got a ruler and measured them, they would be the exact same. Let's just try a little test here. If we draw from here to here, okay, see how I did that? Now let's check. Is this side equal? Let's see, can we line it up? Oh yeah, it's the exact same. It's perfectly equal. And let's do a test for this side. So this is opposite sides. So this side and this side are equal. Let's do the same test here. Okay. Oops, it didn't make a line. Let me try again. And again, if I write it, you write it. So make sure you're doing this as well. Okay. Oh man, it is not wanting to show up. There we go. All right, so this side, I've drawn my line. Okay, let's flip it over and test it out. Oh, look at that. These are exactly equal. It looks exactly the same amount. So opposite sides are equal in a parallelogram. So that's another thing we look for is side lengths. Side lengths. In addition, opposite angles have the same side. So this angle and this angle, opposite, are going to be the same. And this angle and this angle opposite are going to be the same. And if we had a protractor, we could measure them and we'd see they're the exact same. But we can do another test, which is easy. You just, let's see, let's test it. I'm going to draw a line here, draw a line here. Okay, now let's put the other side in it and see if they're the exact same. Yep, look at that. They fit in, it fits in there perfectly. It's the exact same. And let's test this one out. Okay, so that's this obtuse side here. I'm going to flip it over, and look at that. It fits in just perfectly. So I can tell that these are the same and these are the same. Okay, so to be a parallelogram, all you have to have opposite sides being parallel. That means going on forever in the same direction and never touching. Parallel, the side lengths, and then angle size. So you have to look at that, okay? And let's check again about the parallel lines. Let's see. If I go on forever here and over here, okay, so I see my line and I could just keep extending that, and I could extend this one. And I can see, look, they didn't cross. Even though they're at the same place, left and right, they're not going to cross. These are just going to keep going and keep going. They have the same distance apart. They're parallel. These lines will not be running into each other. Look at this. I can just slide it up and down here. It's never going to touch. See that? It's hard for me to hold my hand perfectly straight, but you see it's just sliding right in between these, the same distance apart. So a parallelogram has opposite sides being equal, and we can use just like a little line to show that. So this dash goes with this dash, and two dashes goes with the opposite side. Another math symbol for parallel we can use is a triangle, or a little like arrow. So this side and this side are parallel, and this side and this side are parallel, and then the angles. Okay, now let's move on to the rectangle. Now a rectangle has opposite sides that are equal in length and parallel, and it has 4 right angles. So it's basically the same as this, but what's new? Opposite sides equal, length and parallel, that's the same, but here's the new part, 4 right angles. Remember our right angle, okay, we often see the little square, it comes to a perpendicular intersection, it's 90 degrees. So a rectangle is like a parallelogram, but basically instead of being slanted, these lines just straighten out into a 90-degree angle. So if we put these two next to each other as one shape, this whole shape would be a rectangle. You can see that we have this side being equal to this side and this opposite side being equal. The lines are parallel, they're never going to touch, and we have a nice right angle. It's nice and straight. So that's what a rectangle is. So if we're going to use our math notation, these little symbols, we could say, okay, this side is parallel to this side, the same length. And this side is parallel to this side, and this side is parallel to this side. Remember, I've told you lots of times that mathematicians like to make shortcuts so that anyone can understand. Not just a few people that speak the same language, but any mathematician anywhere. Okay, now we have a rhombus. Now, a rhombus and a square are pretty similar. So I'm going to skip to square because that I think you know a lot better. A square has opposite sides that are equal, in length and parallel. It has 4 right angles, but what's new, what makes it different than a rectangle is that it has 4 equal sides. 4 equal sides. So that's what's new. So everything here, rectangle and square, is the same, but when you have a true square, these sides are all going to be equal, whereas the rectangle has a length and a width, a long side and a short side. Square is equal all the way around. And of course, it has those 90-degree angles, just like the rectangle does. Okay, so that you know a square. But so here's where we get a rhombus. Now, a rhombus is kind of like a parallelogram in that it's kind of squinched over a little bit. It's like a square that someone just tipped. And they just squished him down a little, and he went, whoa, and bent. So from being straight, like this, just kind of went to the side. You see that? But it has a lot of the same properties. So it has the opposite sides being equal. So this side is the same as this side, lengthwise, right? If we measured it. And this side is the same as this side, measurement-wise. And then it has the opposite sides are parallel, right? They're going straight forever. They're never touching. Okay, but what it doesn't have is no right angles. So it's similar to a square, but no right angles. No right angle. And it's also similar to a parallelogram, except for in a parallelogram we only have opposite sides equal. We don't have all 4 sides equal. It's basically if we cut this part of the parallelogram down a bit, chopped it off a bit, then we would get that rhombus shape. Okay, so that leaves us with this poor guy, the trapezoid, who's not exactly like the others. The others have kind of similar partners, parallelogram and rhombus, rectangle and square. But the poor trapezoid is just a weird shaped quadrilateral. It has 1 pair of parallel sides. So just this top part, see how these could extend out if I extend them. Like that, see? And I extend these lines out. Oops. These are never going to touch, right? They're just going on and on and on forever. But they're parallel. They're not going to touch. But the other sides, you can see they are going to intersect. Look, they're here, and already with my hands, let's get the light in here a little bit. You can see already with my hands, they're touching. Okay, they're starting out like this, and they're going to cross. You can see here if I'm drawing it like this and extending those lines out. Extending those lines out, whoop, right there, see? They've crossed. So this is not parallel because these lines intersect. Okay. Stay with me because we're going to do some practice with this in class. But a rectangle, a square, and a rhombus each have all of the attributes and characteristics of a parallelogram, so they are also parallelograms. So because a square fits this, opposite sides equal, opposite lengths equal, opposite angles the same, it's also a parallelogram. And a rhombus is also a parallelogram because it has this. Opposite sides equal, parallel, opposite angles have the same size. And also a rectangle. So they all kind of count as parallelograms. Okay, it's almost like a parallelogram is kind of the parent. Okay, they count as parallelograms. But just because you're a parallelogram doesn't mean you're a rhombus, doesn't mean you're a square. Okay. So let's see. Classify the quadrilateral in as many ways possible. So the quadrilateral has opposite sides equal in length. Okay, opposite sides equal in length. And opposite sides parallel. It also has, looks like it has 4 equal sides. So it is a, Well, if I'm looking here, opposite sides equal in length and parallel, 4 equal sides. So it's a rhombus. Rhombus. But because it's a rhombus, it's also a parallelogram. But a rhombus is a better name for it. This is kind of like a surname, right? So your surname, like my surname is Russell. But there's a lot of Russells in the world. But I'm